And the last kind of logarithmic equation we see here in 4.4 would be one where every term in the equation is a logarithm. A little different approach here. In fact, it's actually quite a bit easier. If we can have every term in the equation be a logarithm, we will work towards taking any logarithmic equation we see and getting it into the form of log of one side equals log of the other, because if we have that, we can use the uniqueness or one-to-one property of logarithms just like we had for exponents. If log of m equals log of n, then m and n need to be equal. The insides are equal. The same thing we did with that same base approach with exponential form. So, looking at an equation where everything is a logarithm, the right side already is a single logarithm, log of this thing here. So this side over here with the subtraction, combining those two logarithms, we'll take the time to do our logarithmic property of this divided by this. X plus 2 divided by 4x plus 3, combining it into a single logarithm. And that's all it takes is that property to get log of something equals log of something to then make the jump to x plus 2 over 4x plus 3 equals 1 over x. Ditching the logarithms, getting those x's outside of them, and being able to solve this equation. Now, this is a rational equation, and so our property, our approach here is always clear the fractions first. So we'll multiply both sides by the LCD of both fractions to do the clearing. So I'll multiply this right side and left side by the LCD of these two denominators, which would be x and 4x plus 3. In this case, that's what it takes to find the LCD, which is just that factor and that factor. So there, those cancel. The x is left, actually I'll just write this. X is left outside of x plus 2. Over here, those cancel, and that's just a 1 times 4x plus 3. Do a little distributing, x squared plus 2x. And you'll notice again, we have an equation that's not linear, right, x squared. So let's bring everything over to one side, subtract over the 4x and subtract over the 3, and then factor. That'll break down to x minus 3 and x plus 1. And so those will give me my solutions, or my proposed solutions, of positive 3 and negative 1. Okay? So positive 3 and negative 1 for my two possible answers. Now we'll go off to the side here and check the domain. Checking the 3 inside of each one of all three of my logarithms here. So we're going to have x plus 2, which will just be 3 plus 2, 5. That's okay. 4x plus 3 would be 4 times 3 plus 3. So 12 plus 3, so 15. That's okay. And then the other one, 1 over x, so 1 over 3. So that's okay. So 3 plugged in, all those work. That's checking x equals 3. Checking x equals negative 1. We're going to have the first one, the x plus 2 will be negative 1 plus 2, which is 1, but that's okay. 4 times x plus 3, the next logarithm will be 4 times negative 1 plus 3. Negative 4 plus 3, which is negative 1. So notice it's not just the case that it's negative that immediately causes the issue, but if it causes what's inside the logarithm to be negative or 0, that's the issue. Right there, that tells me we can't have that, tells me we can't have that, tells me 3 is the only solution. Also, I will mention that if both or all of your solutions fail the tests, then after all this work, if you have no solutions, then that's our answer. No solution. So just be aware that can happen.